All right, guys, I've got good news and I've got bad news. And I always go for the bad news first. The bad news is this is my second time recording this today because the first time it did not record my voice. Boo. The good news is this is our last real unit in Algebra 1. Yay! And then hopefully I'll never have to make any more math videos ever again. And I can let my brain dissolve into oatmeal as it should. This is Unit 7, Lesson 2, creating a model from a graph. We're going to start with a check-in. The function f of x is equal to negative x squared plus 130x minus 1800 represents the relationship between profit in dollars and the number of items sold. Which variable represents profit and which variable represents the number of items sold? So it wants us to interpret this formula in reference to the information it gave us. So if you stop and you look at this, you can see f of x is interchangeable with y, and it's going to be our total. And the total, given the information we have, is going to be our profit. Okay? And then you can see x here and here. So x is going to be our variable that changes. So the variable here is going to be the number of items sold. So in this case, the input is x, and it's the number of items sold, and the output is f of x, which is the profit in dollars. Here is example number 1. When an object is thrown upward from the ground with an initial velocity of 24 feet per second, its height is modeled by the function f of x is equal to negative 32x squared plus 24x. The graph of the function is shown. What is the maximum height of the object? During which periods of time is the object going up and falling down? And after how many seconds does the object reach the ground? Well, you can look right here and see this is as high as it gets. So this is our maximum height. And if you follow it over here to the y-axis on height, you can see it's about 4.5. So 4.5 feet is our maximum height. During which periods of time is the object going up and falling down? You can see right here is the difference between when it goes up and falls down. So the dividing point is going to be between 0.25 and 0.5, which I would say is like 0.33 or something like that. And it means between 0 and 0.33. It's ascending, and between 0.33 and 0.75, it's descending. And they're smarter than me, so it's 0 to 0.375, and then from 0.375 to 0.75. And our final question is, after how many seconds does the object reach the ground? So we throw it, it goes up, it comes back down and hits the ground at 0.75 seconds. Okay, most of this lesson is extremely easy. It's just interpreting graphs and formulas. Which of the following representations of a function provides a visualization of the function's behavior? The function's algebraic expression, the function's graph, or a table with the function's values? Which one of these things gives you a picture of what the function looks like? It's the function's graph, because you can look at it and see what it looks like. If I look at this, I have no idea what the function looks like. If I look at a table full of values, I have no idea what it looks like. But the graph, yeah, I know it's a parabola, or it's a line, or it's exponential. Here's example 2. Ivy is walking home from the grocery store. The distance between her home and the store is 1,200 feet. For the first half of the way, Ivy is walking at a constant speed of 150 feet per minute. For the second half of the way, Ivy speeds up and is walking at a constant speed of 200 feet per minute. Sketch a graph of Ivy's walk from the store to her home as a function of time. Now, because this is an online class, you do not have to sketch anything at the end of the lesson, so we're just going to walk through how you would do that. So to sketch the graph of Ivy's walk from the store to her home as a function of time, you first need to identify the key features of the graph given in the description. First, the distance from the store to home is 1,200 feet. So we're going to start at 1,200 feet because home is at 0 feet, okay? As Ivy starts walking, her distance from home will be 1,200. This corresponds to the y-intercept on the graph. So that determines what our y-axis is going to be and where we're starting from. For the first half of her walk home, which is the first 600 feet, so until we hit this point, okay, Ivy is walking at a constant speed of 150 feet per minute. That means that she's going to drop 150 feet for every 1 minute. Drop 150 feet for 1 minute, because this is a negative slope. This means Ivy's distance from home is shortened by 150 feet after each minute. This allows you to identify the points on the graph, okay, up to 600, because that's when her slope, her rate of speed changes. For the second half of her walk home, which is the last 600 feet, Ivy is walking at a constant speed of 200 feet per minute. This means Ivy's distance from home is shortened by 200 feet after each minute. So now we're dropping 200 feet instead of 150 for each minute. And that allows you to identify the other points on the graph. Here we're dropping by 150, so from 1200 to 1150, to 1050, to 900. Now we're dropping by 200, so 600 to 400 to 200, okay? That's how you would sketch the graph. Here's question number 1. Mike is driving home from college for Thanksgiving. The graph shows the distance from Mike's college to his home as a function of time. How long will it take Mike to drive home? So this is your turn. You need to find this answer for yourself and pause the video and then come back and see if you got the right answer. So how long is it going to take for him to drive home? Long means time. Home is when he's at mile 0, so it's going to take him 90 minutes to get home. 90 minutes. Okay. Pachink. Here's question 2. Mike is driving home. During which time does Mike drive the fastest? Pause it, figure it out, and then come back. Okay, the fastest is when the slope of the line is the steepest. And you can see he's slowing down the closer he gets to home. So he's traveling fastest during this section. So we need to look at the time and see when he's driving this speed. So from 0 minutes to 20 minutes. So during the first 20 minutes of his ride, he is, oh my goodness, where am I? Mike, come back, Mike. Right here. During the first 20 minutes of his drive, I apologize, he is driving his fastest. Okay. This is practice question number 1 at the end of your lesson. Mike is driving home from school for Thanksgiving, and it's all the same information. How many miles from home is Mike's school? Pause it, figure it out, and come back. So we need to look at miles. He's starting at school, so his school is 100 miles from his home. 100 is your answer. Practice question 2. A local store is selling heaters. The graph represents the profit made as a function of the number of heaters sold. How many heaters does the store need to sell to make a profit of $700? Pause it, figure it out, come back. Okay, we need a profit right here of 700 right here. So we're going to follow it across until we hit our line and then follow it down. And that tells us they need to sell 40 heaters. So your answer is 40, 40. Here's quick check question number 1. I will not give you this answer, but I'll tell you how to find it. Rania is heading home from work. Along the way, she stops at the grocery store to buy some fresh vegetables. Shown here is the graph of the distance from Rania's home to her workplace. Interpret the graph. How long does it take Rania to get home? This is work. This is home. So how long does it take her to get there? You need to be looking at the minutes axis and figure out when she's home. Here's quick check question number 2. Smart Computer makes and sells laptops. The graph here shows the revenue of Smart Computer as a function of the number of laptops sold. Interpret the graph. How much revenue is earned if 75 laptops are sold? So you need to look at your 2 axes and figure out which one talks about how many laptops are sold. Then you need to figure out where 75 is, follow it up to the line, and then follow that line over to the opposite axis, and that will give you your dollar amount. Linear function review. Linear functions are written in the form f of x, or y, is equal to mx plus b, where m is the slope and b is the y-intercept of the graph. Slope can be found by using the formula m is equal to y2 minus y1 divided by x2 minus x1, where the y and x's are just 2 points that are anywhere on that line on the graph. A linear function will always be a straight line on a graph. No curve, no bend, perfectly straight. Which of the following equations can be used to model a graph of a straight line? We just read about that. Were you paying attention? F of x, or y, equals mx plus b. So here's example 1. The graph represents the cost of garlic in pounds. Create a table with at least 3 function values, and then create an equation to model the graph. We'll do this together. It's actually really easy to create the table because all you have to do is look at this graph and look at the points that it gives you, okay? So the first one is 0, 0. The second one is at 2 and 9, and the last one is at 4 and 18. Now, I know you can't really tell specifically where these numbers are, but it gets better in a minute. Just let the book be stupid, okay? Then, what you're going to do is create an equation to model the graph. So we have coordinate points now. We need to figure out what the slope is. And to find the slope, you use the formula y sub 2. So we're going to take this one, 9, minus y sub 1, which is 0. We're going to take that one right there and divide it by y sub 2, which is, this case is 2. I apologize, x sub 2, divided by x, subtract x sub 1, which is going to give us 9 divided by 2, which gives us 4.5. So our slope is 4.5. So in our formula, we have f of x is equal to m, which is our slope, 4.5, x, plus, and then we have b, which is our y-intercept. And the y-intercept right there is 0. So we don't need to write that little bit right there because 0 is just a placeholder, and there's no need to write the placeholder. And there's our formula right there. F of x is equal to 4.5x. Here's another check-in. Which of the following equations can be used to model a function whose graph is a parabola? This lesson did not remind us what that formula looks like. Do you remember what it is? The formula for a parabola is f of x is equal to ax squared plus bx plus c. If you don't already know that, you should probably put it in your notes. Okay. Here's example number 2. Given is the graph of a product of 2 real numbers whose sum is 20. First, create a table with at least 3 function values based on the given graph, and then create an equation that models the graph given. Again, we'll do this together. So first, to create a table, you're just going to you need to find at least 3 values that cross these grid lines really nice and neat. So our first one would be 0, 0, because that's really obvious. Another really obvious one is 20, 0, because it hits that x-axis there, okay? The maximum right here crosses both grid lines really nicely right there. So 10, 100 would be a really obvious one. They also chose to include 5, 75, and 15, 75. Because it's a parabola, these mirror, you're going to have 0, 75, 100, 75, 0 for your y-axis, okay? Now that you have those, we need to figure out the formula. So our formula is going to be written in this form. We know what c is. It's 0 because that's the y-intercept. Because it's 0, that becomes a placeholder, and we don't need to include that in our final formula. So we're going to just need to solve for a and b now. This is a little complicated. I'm going to show you how to do it. Don't stress too much. At the end of the lesson, you don't have to be able to solve all the way through to A and B. I'll show you how far you have to go, okay? So the first thing that you're going to do is you're going to take 2 points from the table and use them to solve for A and B. They want us to use this point right here and this point right here. So we're going to take this original formula, except we don't have to include C for this specific problem, and we're going to plug these values into them, okay? So our first problem is going to be f of x, in this case is 75, okay, is equal to a times x squared, so a times 5 squared plus b times 5. Okay, I'm using this set of coordinate points right here. Now let's simplify this. So this one ends up becoming 75 is equal to 25a, because 5 times 5 squared is 25a, okay, plus 5b. All right, so there's our first one. Let's do our next one with these coordinate points. So f of x is 100 is equal to a times 10 squared plus b times 10, and that's going to simplify down to 100 equals 100a plus 10b. This is as far as you have to go in the quick check. You just have to be able to find these two formulas. So I'm just going to cut all the rest of this out. Skip the rest of that last problem because it is almost bedtime and I've already done this lesson once today and it doesn't matter in the end, so whatever. Here's question 1. Find the equation that models the linear function given in the value table. So pause it, figure it out, come back. Okay, we know right from the get-go that this is a linear function, so that means we're dealing with the formula f of x is equal to mx plus b. Okay, so the y-intercept is where x equals 0, so b has to be 3. Okay, we can see that right there. Now we just need to find the slope. X is going to stay there. So let's just take these first two. It has to be two consecutive sets of numbers to find the slope. So we have y2, which is 4.5, minus y1, which is 6, over x2, which is -1, minus x1, which then makes it a positive 2. So 4.5 minus 6 is going to give us a -1.5 over a -1, which is going to give us a positive 1.5. So there is our final formula. F of x is equal to 1.5x plus 3. Okay. Here's question number 2. Given is the graph of the height of a ball. I need my eraser. Eraser. As a function of time, when it is thrown vertically upward, create a table of at least 3 function values that model the function. Number 2, given is the graph of the height of a ball as a function of time. When it is thrown vertically upward, create a table of at least 3 function values that model the function. Pause the video, do it, come back. Okay, the first obvious one is the y-intercept, where x is 0 and y is 5, which is right here. The next obvious one is the maximum, where x is 4 and y is 9. And the last obvious one is 0 and 10. Well, 10 and 0. I apologize. I said those in the wrong order. Here is practice question 3. This graph shows the total distance traveled by a car driving at a constant speed of 60 miles per hour. Based on the information from the graph, complete the table as shown here. So at hour 1, how many miles have we traveled? Boop, 60. You should be doing this on your own. I'm sorry. Okay, at 180 miles, we've been traveling for 3 hours. And at 4 hours, we've traveled 240 miles. Yippee skippy. Here's practice question 4. The graph represents the cost of renting a car based on the distance traveled. Find the equation of the linear function that models this graph. Linear means our formula is f of x equals mx plus b. Pause it and figure it out, then come back. B is our y-intercept, so that's going to be 20. And our slope, we need 2 consecutive points. So we have one here at 0 and 20. Hello, you're so wonderful. And another obvious one here is 20 and 25. 20, 25. So y2 minus y1 over x2 minus x1 gives us 5 over 20, which gives us a slope of 1/4 or 0.25. Either is a correct answer. Here's practice question number 5. Given is the graph representing the area of a rectangle whose perimeter is 16. Using the graph, complete the table as shown here. Pause it, come back. Our first one is 0 and 0. Our second one is 15 on the y-axis. Coming over, it looks like it's about 3. And the last one is 7 on the x-axis. Coming up here to 6. Here's quick check question 3. Quinn's family is going camping. To get into a camping site, his family must pay a one-time parking fee and purchase a ticket for each family member. The graph shows the total cost Quinn's family must pay to enter. Which of the following points can be used to find the linear equation that models this graph? So you're looking for 2 points that can help you find the linear equation. I will give you a hint. The 2 points must help you determine the slope. You can do this. Quick check question 4. The graph here represents the height of a ball when being dropped from a height of 16 feet. Which of the following points can be used to find the quadratic equation that models the graph? So now we need to find a quadratic equation. That means the formula of the equation is going to be f of x is equal to ax squared plus bx plus c, which is this big complicated one we did back here. Okay, that's the same type of formula. So in order to find this formula, what points do you need? Okay. Now here's quick check question number 5. The graph represents the area of a rectangle whose perimeter is 16. The graph is modeled by a quadratic equation in the form of f of x is equal to ax squared plus bx plus c. Given that c equals 0, using the points 3, 15, and 6, 12, which system of linear equations can be used to identify the coefficients a and b? So this is the one question we had that wasn't just like really obvious. You need to find the 2 equations that can identify the coefficients a and b. So you're going to use this coordinate pair and this coordinate pair. You're going to use this formula. You'll stick this one in first to come up with the first equation and simplify. You'll stick this one in second, come up with a second equation and simplify, and then find them down here. Also, if you're paying attention, if we're trying to find the answer, the formula for this, how many coordinate pairs did we need? This says break slide because when you're watching a presentation, sometimes the presenter will be really nice and give you a break. So let's go break something.